Okay. I want us to use this video to just practice simplifying square roots, because we're going to use that when we have to solve for x that require knowledge of square root math. So remember a square root, okay, looks like this. We don't write the square here, by the way. There is a 2 there, we just don't write it. When there's nothing there, we know as mathematicians it means square root. When we talk about square root, we're looking for 2 numbers that multiply to whatever's under the square root symbol. In this case, the answer is 4. Because 4 times 4 is 16. Square root of 36 is 6, because 6 times 6 is 36. Those are called perfect squares because the answer are nice and neat like that. But what happens if you get something like the square root of 12? Well, there are no 2 numbers other than decimals that when you multiply them together, will you get a 12. So what we need to do is we learn how to simplify. And the method you're going to use to simplify is you're going to take the 12, okay, you're going to take the 12 and you're going to create a tree of factors. 12 is the same as 2 times 6, and 6 is the same as 2 times 3, okay, and these are taking it down to prime numbers. And once you take it all the way down as far as you can go, meaning 2s and 3s or 5s and 7s, prime numbers, when all your leaves are prime, you're done. And notice that 12 is the same as 2 times 2, which is 4, and 4 times 3 is 12. So here are my leaves, my outermost leaves. So I'm done making my tree. When you're done making your tree, because we're talking square roots, look for pairs. Look for pairs of numbers that match. And in this case, I have a pair of 2s. And every time you have a pair, you can take it out of the radical. So we started off with the square root of 12, and I have a pair of 2s. I can take the 2 out as 1. I take it out as 1. Not as 2 2s, but as a 2. Every pair comes out as 1. And whatever doesn't pair up stays under the radical. So if I simplify the square root of 12, it's 2 root 3. The way you look at it is this. If you can create a pair, meaning somebody has a friend, the same person friend, 2 are the same, that every time you match up, create a friend, the friend can leave the house. They can get out of the radical and leave. These pair, this is a pair, these are friends, they can leave. If you don't have a friend, you're an orphan. The orphan stays in the house, doesn't get to go. So the 3, which is orphaned here, stays under the radical, stays in the house. Let's do another example, square root of 63. I know it's a corny example, but it's the best I can come up with. 63 is 9 times 7, and 9 can be written as 3 times 3, so we have 3, 3, and 7. Those are all prime, we're done. Now we look for pairs. Yep, the 3s are together, there's a pair right there. We could take it out, the 7 is an orphan, he's got to stay home. So square root of 63 is 3 root 7. Okay, let's try another one. Square root of 243. Well, the square root of 243. So we take 243, that's 3 times 81. And 81 is the same as 9 times 9. And 9s are 3 times 3, and 3 times 3. So my outer leaves a whole bunch of 3s. Now, do I have pairs? Well, I got a pair right here, I got another pair right here, and I have an orphan right here. So this pair of friends, they come out. This pair of friends gets to come out. And this 3 is an orphan and stays home. Now, what you can do is you multiply to 3 times 3. Okay, so every pair that comes out, before you're done, you can multiply those guys together. The one other simplification thing we need to be able to do is make sure we don't keep radicals in the square roots in the denominator. If I gave you a problem and you had 2 square root of 3, we don't want to keep radicals in the denominator. It just goes against convention. The way you get rid of them is you multiply by whatever that radical is in the denominator over itself. Remember, this 5 over 5 is 1, 2 over 2 is 1, root 3 over root 3 is 1. We're not done anything to the problem. This is like multiplying by 1. Anything over itself is 1. But the net effect of doing this, by taking this radical and multiplying it by a form of 1, which in this case is formed as root 3 over root 3, okay, 2 times root 3, and root 3 times root 3. Anytime you have a square root times itself, okay, it's the same thing as just getting rid of the radical. Root 5 times root 5 is 5. Root 4 times root 4 is 4. Root 11 times root 11 is 11. Root 3 times root 3 is 3. What we've done is we've removed the radical from the denominator by multiplying it by 1. The formula of 1 being whatever this radical is over itself, and then multiplying the numerators. 2 times root 3 is just 2 times root 3. You do not multiply the 2 in. It's just 2 times root 3. And then root 3 times root 3 is 3 for this reason. So I just want to make sure, in addition to simplifying like this, that you can also get rid of radicals when they appear in your denominator. And this work with square roots is going to help us solve for x in another video. Take care.